What we have here is a lighting protection system that has been in this building for 25 years. We're going to now take a look at what the resistance to ground of the electrode here on the corner is. We have a system that's been run on the walls. It runs through the attic. The lightning rods poke up through the ridge. We put ornamental glass balls on, which are a matter of choice and not of necessity. The down lead, which you'll see in a sec, comes down here in the corner. We're going to clamp to it. We're going to go out 100 feet with a test probe, and then 62% of that, which is going to be 62 feet, with an auxiliary probe. We're going to generate DC current in the ground to test the resistance of this exact electrode. We're shooting for 25 ohms, but the soil may dictate otherwise. Corrosion may have an effect on the ground system as well. So this is our meter. We are going to connect over to the wall where the down lead is. Now the owner of this building put the lightning protection system in during construction, which is nice. So if you're planning something, we'll be happy to price it as you're doing design. We can even do some design for your bid package. And make sure that you get it in the bid phase. Now, Seth's going to go out 100 feet. I'm going to go out 62 feet. Hey, Seth, we're going to have to go at an angle like this, because my 62 feet will end up in the driveway. We'll have to whack a hole in the driveway. Don't want to do that. Now this meter here is it's a Unilap Geo10. It's a German meter. It's very versatile. Probably about $5,000 worth of meter here. This is the test probe. Doesn't have to go in very far. That cable comes down and terminates 2 feet below grade at a 10-foot driven copper-clad 3/4 inch ground rod. Other grounding sources can be a counterpoise system, which the actual next building does have. The lighting system connects to water pipe, cable TV, telco, any structural steel, gas or oil piping, pretty much all potential bodies of inductance that lightning might jump to. All right, so we turned on the meter. We're going to generate a DC voltage in the ground here. Do a test, and resistance to ground is 5 ohms, which is pretty good because we're shooting for under 25 ohms. And this is important if you've got, I don't know, plasma screen TVs or computers or lots of Levitron dimmers or any kind of high-end expensive electronic equipment in the house, making sure that resistance is low.